Verifying trigonometric identities is the topic. So let's do the first example. Verify the identity 1 over 1 minus cosine square is equal 1 plus cotangent square x. So it's pretty hard to start from the left. If you start from the left, you'll be stuck. I mean, you could see it, but not definitely. So let's start from the left and show you why you're going to get stuck. If you do 1 over 1 minus cosine square, that's equal to 1 minus cosine square, you could use number 3. Remember, sine square is equal what? 1 minus cosine square. So you can write this as 1 over sine square. You could write it as cosecant square, but how would you get 1 plus tangent, 1 plus cotangent square of it? So let's do it the other way around. So we'll start with 1 plus cotangent square x. So this is equal 1 plus cotangent is right here, number 2. Cotangent is cosine over sine. But since it's square, we need to square both. Now, since we have the same denominator, we need to get the same denominator, so multiply. Let me rewrite it. This is like 1 over 1 plus cosine square over sine square. Right? Now, this is what, since we have this, the common denominator will be sine square, so I'm going to multiply sine square at the bottom, sine square at the top. So this will be equal sine squared plus cosine square over least common denominator, but we know that sine square plus cosine square is just 1, right here, number 3. So that would be 1 over sine square. We're almost done. We need 1 over 1 minus cosine square. However, we know that sine square is just right here. It's just 1 minus cosine square. And we're done. So you could have gone the other way this way, but it's not evident in the beginning. You could have gone this way now that we know how to go that way. So you could rewrite 1 as sine square plus cosine square and so on. So let's do the second example. Second example, we could do it either way. So how? Let's start from left first. If you start from left, sine square over 1 minus cosine x, this is equal what? Remember, we need to get 1 plus cosine, but we know that sine square is just 1 minus cosine square. It's right here, we just used it. So 1 minus cosine x, but see again, always look at what you're looking for. We're looking for 1 plus cosine, but if you just write 1 is the same thing as 1 squared. If you look at the top, you can factor the top. 1 minus cosine, 1 plus cosine. That's the difference square identity from algebra. Now if you do that, you simplify 1 minus cosine, and then you'll get, and then you get 1 plus cosine x. Now to go backwards, you have 1 plus cosine x. The thing is, if you want to go backwards, you look and you want to have, you're looking at the left side and you see that the denominator have 1 minus cosine. So what you say to yourself, well, this is like 1 plus cosine over 1. I need the 1, let me rewrite it, 1 plus cosine over 1. So you're like, I need 1 minus cosine to show up in the denominator. So what I do, I multiply 1 minus cosine, both the numerator and the denominator. When you do that, you realize that this is just 1 minus cosine, but then when you FOIL the top, you get 1 minus cosine squared, which is just sine squared. So it's as easy to go from right to left or left to right. Alright, and that's it for these examples.